Graph the following polynomial function. Our polynomial equation is in factored form, so it's easy to identify the x-intercepts. Just set f of x equal to 0. That's like saying y equal to 0. Now you have this. For a product to equal 0, one of the things you're multiplying should already be a 0. That's the only way you could get a 0 when you multiply. What you're multiplying has a 0. Maybe all of them are 0. So if x plus 1 equals 0, then x would have to equal negative 1. If x minus 2 equals 0, then x would have to equal 2. If x minus 7 were 0, or equal to 0, then x would have to equal 7. These are the x-intercepts. Now multiply the factors. So these two will give you this. And then multiply these two, that would give you this. Now that you have it multiplied out, identify the degree. Remember, the degree is the highest power on the variable, so the degree of this polynomial is 3. If the degree is 3, the end behavior of the graph is in opposite directions. That means the graph of this polynomial at the ends are pointing in opposite directions. And then, by looking at the leading term, x to the third, look at the sign. Since it's positive, their endpoints are pointing in opposite direction in this manner. The left is falling and the right is rising. So falling, rising. So when we graph our polynomial, we know that this end's going to be falling and this end is going to be rising. Here are the x-intercepts. Now we're going to find a y-intercept so you can get a better graph. So remember, the y-intercept you find by letting the x equal 0. So you replace the x's by a 0 in the polynomial equation and you get a y equal 14. So that at x equals 0, y equals 14. So that would be right here. Now just connect these points with the information we had already found, and the polynomial looks like this. And we know that polynomials have to be smooth with no breaks, no sharp corners. So this would be an approximation of the polynomial we were supposed to graph.